In our previous video, we have discussed in very depth how to find axis of rotation omega cap and an angle theta up to which we have to rotate a vector for a given rotation matrix. From this, we have made shortcut formulas. The algorithm of the matrix logarithm of R. Given R belong to SO3, find the theta belongs to closed interval 0 pi and the unit rotation axis omega cap belongs to R cube, where mod of omega cap is 1 such that e raised to skew symmetric omega cap into theta equal to R. The vector omega cap into theta belongs to R cube, comprises the exponential coordinates of R for R, and the skew symmetric matrix omega cap into theta belongs to SO3 is the matrix logarithm of R. There are three cases we have discussed in depth in our previous video. You should watch this video before this video. A, if R equal to I, identity matrix, this is rotation matrix, then theta equal to 0. We are not rotating at all, so omega cap is undefined. Axis rotation is undefined because we have not rotation applied. B, if trace of R is what? The sum of diagonal elements of rotation matrix is -1, then theta equal to pi. Then set omega cap equal to any of the following three vectors. That is a feasible solution. Here omega cap we have adjusted in a simple manner. You should watch our previous video before this. 1 upon root of 2 into 1 plus R33, column vector R13, R23, 1 plus R33. Or for omega cap we can use this formula also. 1 upon root of 2 into 1 plus R22, R12, 1 plus R22, R32, equation 3.59. Or omega cap equal to 1 upon root 2 into 1 plus R11, column vector 1 plus R11, R21, R31. This is equation 3.60. You can use any of the three to find omega cap. Note that if omega cap is a solution, then so is minus omega cap also. See, if the angle is not pi, not 0, then theta equal to cos inverse half into trace of R minus 1, where theta belongs to close open interval 0 pi. We have discussed this formula. And omega cap skew symmetric is 1 upon 2 sin theta R minus R transpose, equation 3.61. Since every R belongs to SO3 satisfies one of the three cases in the algorithm, for every R there exists a matrix logarithm skew symmetric omega cap into theta, and therefore a set of exponential coordinates omega cap theta. Okay. Because the matrix logarithm calculates the exponential coordinates omega cap into theta, satisfying mod of omega cap theta is less than or equal to pi, because of magnitude of omega cap is 1 and theta we have taken between 0 to pi. We can picture the rotation group SO3 as a solid ball of radius pi. See figure 3.13, this one. This is the circle of radius pi. These were x-axis, y-axis, z-axis. Omega cap is axis of rotation. And we have drawn a sphere of radius pi, not circle, sphere of radius pi. So given a point R belongs to R cube in this solid ball, let omega cap is R by mod R. If a vector is divided by its magnitude, we get a unit vector in the direction of that vector. Be the unit axis is the direction from the origin to the point R, and let theta equal to mod of R. See here, suppose omega cap theta is r vector. Suppose omega cap theta is r, implies r by mod r. We get a unit vector in the direction of r vector. So it is nothing but omega cap. So r by mod r is omega cap. Now using this, what is r? R is omega cap theta. So this r is replaced by omega cap theta. This as it is, this as it is. So omega cap cut out. So mod r is nothing but theta. Mod of r is nothing but theta. So and theta is maximum value of theta is pi. So for any r, this is the vector inside a sphere of radius pi, and the magnitude is nothing but angle theta. So point r, and let theta equal to mod of r be the distance from the origin to r, and this is the distance is actually theta, angle theta, so that r vector r is omega cap theta. The rotation matrix corresponding to r can then be regarded as a rotation about the axis omega cap by an angle theta. For any r belongs to SO3 such that trace of r not equal to -1, that is theta not equal to pi, there exists a unique r in the interior of the solid ball such that e raised to skew symmetric r, that is omega cap skew symmetric into theta, which is r. In the event that trace r is -1, log r is given by two antipodal points on the surface of this solid ball. That is, if there exists some r such that r equal to e raised to skew symmetric small r with mod of r equal to pi, then r equal to e raised to skew symmetric of -r also holds. Both r and -r correspond to the same rotation r. That's it.